All right, so 13 is actually one that's been on the worksheets you guys have done previously. Definitely fair game for me to grab anything off a knowledge check, recover, or worksheet. So in this case, no context, no crazy ass word problem, but we are asked to find two different things, the perimeter and the area. So let's tackle the perimeter first. So as a reminder, do not include the dashed line in the middle. We only want the outside lines. So we have a 17, a 12. This little line here tells me that this is the same measurement as that. So this is also a 12. And the only piece I don't know is that line. But we can recognize already that it looks like it's the hypotenuse to this right triangle, right? There's a right triangle here. So, well, if that's a hypotenuse, then we can use the Pythagorean theorem. So we need to have our A and our B. This is obviously 12 because it's right across. If this whole thing is 17, but this portion of it is 12, that means the remaining part has to be 5. So those are our A and B for our Pythagorean theorem. 5 squared plus 12 squared is equal to, since this is opposite the right angle, my C squared. So I'm going to go figure out what 5 squared plus 12 squared is. According to my calculator, it's 169. That's C squared, and if I want to get C by itself, I'm going to come through and square root. And it turns out that the square root of 169 is 13. So this last bar right there is 13. So there's my perimeter. Just adding all those things together. What is that, 54? I should actually check my work instead of just saying it. And then making sure we keep our units. Perimeter has the same units as our original figure. All right, so let me pull out a brand new fresh one to calculate the area. All right, so if I'm looking for the area, now I care about the two figures instead of just the lines around the figure. And I can see I have a square, 12 by 12. That's one of my figures. And I have a triangle. So I need to find the area of both of those and add them together because we have both of them in our drawing. So I always start with the rectangle because it's always the easiest. It's just length times width. If this is 12 by 12, the area of my rectangle is 144 square centimeters. Okay, and then I've got my triangle. Well, last time we were clever enough to realize that if this whole thing is 17 and this is 12, the remaining piece, this leg of my triangle, has to be 5. Since this is at the same parallel to this 12 inch, this also has to be 12. And I don't even need the C we calculated for the perimeter because the area of a triangle is 1/2 base times height. So we're adding here an additional, oh my God, my brain can't handle it. It's just 30? So small. So small. But it makes sense. This is clearly not drawn to scale. If this is 12 and this is 5, it should actually be more like this if it was drawn to scale because 5 is less than half of 12. Because I was looking at this and being like, those are very different. And then, of course, since we need both of these figures, we're going to add these two values together. And we got 174 centimeters squared. Gorgeous. So there's our perimeter and our area for number 13.